Hello students, welcome to Akshar IIT Foundation classes. So my name is Shivashankar. I am going to teach physics today onwards. So in the previous classes we have completed about the basic mathematics for the physics, which are the topics which will be utilized in our coming topics. So the basic mathematics we have completed. Now today we are entering into the topic that is actual topic. Okay. So about this topic, already you have studied about the motion. So you have studied about the motion in your previous classes. So today we are going to see based on that concept. It will be the important concept. So which will be asked many questions in online classes. Okay, competitive exams. There are many questions will be asked from this chapter. So that topic we are going to see there. So the topic name is center of mass. Center of mass. See, we have studied in the motion topic. We know about the motion and the rest, how the objects will be moved in one dimensional plane, in two dimensional plane, in three dimensional plane. We have seen there. So in that topic we have considered. So every object is considered as a point size object. As a point size object. But in general, we cannot see the objects are like a point size object. The mass of the object will be extended. Okay. So we can see the object in our surroundings. They are the system of particles, or we can say them, they are the extended objects there. It is the combination of the small particles. Okay. So then the center of mass is what there. Okay. Center of mass is a point. It is an imaginary point where the whole mass of the object seems to be concentrated. So that point is known as the center of mass. Suppose let us see, here an object is there, here an object is there. It is an irregular shape of object. So it is the collection of, there are many points. It is a collection of a combination of, there are many points. And the whole mass of this body, the whole mass of the body seems to be concentrated at one point, so that one point, so where the whole mass of the body can be assumed to be concentrated, so that point is called the center of mass. Center of mass there. Suppose if it is a regular shaped body, so like if you take a square, if you take a square type object, then the mass of the object is along its periphery. Mass of the object is along the periphery. Then this whole mass of the object seems to be concentrated at the center, exactly at the center. So geometric center and the center of mass will be coincided. Okay. So that is called the center of mass. Means a balancing point or an imaginary point where the whole mass of the object seems to be concentrated. So that is called the center of mass. Suppose for irregular shape of bodies, then it may be in the whole mass of the body, it may be in between the mass, or that is based on the distribution of mass. This center of mass will be depend on the how the mass has distributed. Based on that, it will be depend there the position of the center of mass. So suppose if you take a triangular shape of the body, means the mass of the object is concentrated at the edges, at the sides of the triangular shape. Then for this also it will be at the center of this body. The center of mass will be placed. Center of mass will be situated at the center of the object there. So then how to find out? How to find out this position of the center of mass? That we are going to see there. Okay. So center of mass is the imaginary point where the whole mass of the object seems to be concentrated. So that point is called the center of mass. It is a balancing point where if you apply the force on that body, then whole mass of the body is coming into the motion there. Okay. So that balancing point is nothing but the center of mass. Okay. So now we will see there the position of the center of mass. We will see the position of the center of mass. So you can write the definition of the center of mass. definition. The imaginary point where whole mass of the body assumed to be concentrated is called center of mass. Where the whole mass of the body seems to be concentrated, so it is called, that point is called center of mass. So this center of mass is a balancing point. It is a balancing point. And next one is, it is depend on the distribution of mass of the object. Depends on mass distribution. Mass distribution depend on the mass distribution. How the mass of the body has distributed, so based on that it will be depend there. Okay. The next one, there may not be a mass where the center of mass is present. Okay. So suppose if the center of mass, shown the few of the diagrams now, that is regular shaped bodies, if the mass has distributed at the edges of the periphery of the object, so there it will be at the center of the geometrical center of the body. So the center of mass will be at the geometrical center of the body there. So their mass may not be present there. Suppose if you take a bangle, so at the bangle, at the circumference of the circular shape, the mass has distributed there, but the center of mass of the bangle will be situated at the middle, exactly at the center of the bangle there. So it will be, so there is no mass. Even though there is no mass, the center of mass will be present there. Okay. Then how to find out the position of the center of mass, that we are going to see. Understood? The definition of the center of mass is nothing but it is an imaginary point where the whole mass is assumed to be concentrated, is called center of mass, and it is a balancing point. It depends on the mass distribution, and there may be mass may not be present where the center of mass is situated there. So may be present or may not be present there. So even though there is a mass, the center of mass may be present there. Okay, like we can take the example of the bangle. So in the bangle, the center of mass will be at the center of the bangle, but there is no mass there. So like suppose if you take a square, so where at the edges of the square the mass is distributed, then the center of the square where there is no mass, so there the center of mass may be present there. Okay. So now next one we'll see there, position of the center of mass. How to find out the position of the center of mass? Is it completed, children? We'll see there. Next, position of center of mass. position of center of mass. Position of center of mass for a system of two particles. System of two particles. For a system of two particles. Okay. System of two particles. So let us consider, suppose two particles are there here. This is a mass of m1, mass of the object is there, and at certain distance, at a distance d, one more particle of mass m2 particle of mass is present. The distance between them, let us consider the distance between them. It is the distance between them. You consider this is a distance d between the two particles d. And here the center of mass may be present at certain point. Consider that point is, suppose you consider the point is here. Okay, so let us consider the center of mass is here. Here the center of mass is there. Now that center of mass from the first particle, it is at a distance of, let us consider the distance. Let us consider the distance here, r1 distance from here, r1 distance from here, r1 distance from this point, from this point up to here. So now from here, the remaining distance, suppose it is r2, we can consider there. So this is a r2. That is a r2. Then how to find out the position? How to find out here r1? If you find out r1, that is the position of the center of mass. If you find out r2, that is from the m2 mass, the center of mass of the body at the from the m2 mass of the object. Okay, how to find out that? So to find out that, we will be take here origin. We'll take origin there. So we'll be place this object. We'll place this object, first object, at the origin. Now this particle is there at the origin. You consider the m1 mass of the body is at the origin there, and m2 mass of the body is there at a distance from the origin x distance. So let us consider, if we extend this one, let us consider this is the x-axis. That is the x-axis. Okay. So now we'll find out there. Suppose if the mass of the body is moved there. So here we will use, to find out the center of mass, we will use the moment of the mass. Suppose if any external force is applied on this center of mass, then whole particles will be moved there. So how much particle it will be moved? The center of mass will be moved. Then so according to that, corresponding to this particle, mass of the particle, it will move certain distance there. So in that, the same way, the m2 mass of the body also it will be moved there. So let us consider, suppose from the origin, this has a distance r1. The particle has the distance at the center of mass is at r1, and so m2 particle is at d. M2 particle is at d. So now if we consider m1 particle at the origin, so the position of the m1 particle is 0, 0. Now on the x-axis we can find out now this particle. Here the m2 particle in the one dimensional plane on the x-axis, it will be, we can write here d, 0. We can write d, 0. We can write d, 0 there. Now suppose if any external force is applied along the x direction on the center of mass, so that particle has moved r1 distance, so center of mass has moved r1 distance, then this will be at a m1 position. So we can write the moment of center of mass can be taken as, the moment of center of mass can be taken as here. So we can write here. So let us consider mass of the center of mass. The center of mass is nothing but, we have said there, it is the whole mass of the system. Here two particles are there. So now the mass of the center of mass we can write here. It can be represented by capital M, that is m1 plus m2. m1 plus m2 we can write. Now the moment if external force is applied, then from this the moment of the center of mass from the origin, it is at a distance r1. Then from the principle of moment, from the principle of moment, from the principle of moment, from principle of moment, principle of moment of mass, moment of mass. So we can write now the center of mass has at a distance of r1, means mass of the center of mass is, here we can write there capital M. So capital M into distance from the origin, it is r1. Distance from the origin is r1, and that is equals to, so that is equals to, this is equals to, and now the particle, this moment of this particle from the origin it is at, so m1 into we can write here 0, moment of the particle 1, and next plus moment of the particle 2, moment of the particle 2 is plus moment of the particle 2. So from the origin how much distance it is there, moment. So mass into its distance from the origin, that is the moment of the particle. So m2 mass, and the distance from the origin it is at a d. So d distance it is there. Okay. So now, so from this we will be get here m1, sorry, capital M into r1, that is equals to, here m into 0, m into 0 will be 0 only. Then m2 into d, m2 into d. So from that we can write here r1 is equals to m2 into d whole divided by this m, we have to send this side, it will become capital M. So from this equation capital M is nothing but, we can write here, so m2 into d divided by m1 plus m2, m1 plus m2, m1 plus m2. m1 plus m2. So therefore the center of mass, position of the center of mass from the origin, from the particle 1, it can be written as r1 is equals to m2 into d divided by m1 plus m2, m1 plus m2, m1 plus m2. Now done children, this one. So otherwise I write here r1 is equals to m2d divided by m1 plus m2. This is the position of the center of mass from the particle 1 which is placed at the origin, Clear children? Now we are going to find out the position of the center of mass from the second particle. From the first particle it is at a distance r1, and from the second particle it is at a distance r2. So how to find out this r2 value? Okay, r2 value, center of mass. The formula for the r2. So we have formula for r1 we got there, that is m2. So mass of the second particle into distance between the two particles divided by sum of the mass of the two particles. Okay, sum of the mass of the two particles. Now we are going to see now r2 value. How to find out r2? Is it completed? Yes, now we will see that. So from that r2 can be written as r2 is equals to whole distance. See here, this to find out r2, what we have to do there? This is the distance between the particle is small d, and from the first particle r1. So r1 already we got here. So to find out r2, from the whole distance, if you subtract r1, there is nothing but r2, no? So r2 is equals to, we can write d minus r1. So that will get r2. Okay. So now we'll see that r2 is equals to d minus r1, we can write. So r1 value we got there. This is a d minus r1 value, what we got there, m2 into d divided by m1 plus m2, since here r1 is equals to m2 into d, m2 into d, r1 is equals to m2 into d whole divided by m1 plus m2. If you subtract, now we have to simplify this one. So we can take the LCM, m1 plus m2 will be the LCM. We can write d into m1 plus m2 minus m2 into d whole divided by m1 plus m2, we can write m1 plus m2. Next, multiply d for these two masses. So we will get here dm1, or we can write here, so m1 into d we can write plus m2 into d we can write. No problem, d into m1 or d into m2 or m1 into d plus m2 into d we can write. So here minus m2 into d. So whole divided by, we will get here m1 plus m2, Now this, it will be cancelled there, m2d minus m2d plus m2d minus m2d will be cancelled there. So that we will get here, from that r2 is equals to, so m1d whole divided by m1 plus m2. So this is the position of the center of mass, from the second particle, So r1 will be the position of the center of mass from the first particle, So these are the formulas. By using these formulas, we can find out the center of mass of the two system of the particles. So we'll see here one example. Okay. So by that example, we can find out the center of mass of the particle, center of mass of the system of two particles. Okay. It's clear, children? We'll see one example. See. So example we'll see there. One example. Example 1. So let us consider here a mass of 2 kg, and it is displaced with the second mass of the particle, that is, let us consider here 4 kg at a distance of, so this is at a distance of, you consider the distance is here at a distance of 6 centimeters. Okay. Now we should find out the center of mass. We can find out the center of mass. So let us consider at this point, suppose from this particle, from this first particle, from the 2 kg mass of the body, at a distance, it may be r1 distance, and this is r2 distance from the second part, from the second mass, means from the 4 kg mass of the body, it is at a distance, the center of mass will be at a distance r2. So this is the center of mass, you consider there, center of mass. Okay. So now, so R1 formula we got here, so that is equals to m2 into d divided by, so m1 plus m2, no, m1 plus m2. So we can write here r1 is equals to m2. m2 is mass of the second particle and distance between the particles is 6. Distance between the particle is 6. And mass of the body here, sum of the mass of the body, that is 2 plus 4. 2 plus 4, 2 kg and 4 kg. So we will get here this will be the 24, 4 6 are 24 divided by here 2 plus 6 will get 2 plus 4 will get here 6. Okay, how much will get there? 6 ones are 6 4s are 24. So therefore we will get r1 is equals to 4 centimeters. r1 is equals to 4 centimeters. r1 is equals to 4 centimeters. If this r1 is equal to 4 centimeter, then we can find out r2, no? r2 simply we can write here r2 is equals to we can write r2 is equals to d minus, so d minus r1 we can write, so that is whole distance is 6 minus 4, so we will get here 2 centimeters. So therefore r2 will be at 2 centimeters. Means the center of mass is near to the heavier mass of the object. See here, mass is here m2. m2 is greater than m1. No, m2 is greater than m1. m2 is greater than m1 here. So if m2 is greater than m1, we got r2 is lesser value. Means r2 is lesser value means it is near to the heavier mass, and r1 is 4 centimeters. It is far from the lighter mass. It is far from the lighter mass. So here we can write a note. Here we can write a note, that is, so note we can write here, center of mass is near to heavier mass. Heavier mass of the object. Heavier mass of the object. That means the center of mass will be close to the heavier mass of the body. Center of mass will be close to the heavier mass of the body. So now we have, in this example we have seen there, the center of mass is situated along x-axis. Okay, means along in one dimensional plane we have seen there. Okay, suppose if the objects are placed in the plane, in xy plane, object is placed in the xy plane, how the center of mass can be find? So that can be seen there. And here we have seen there only two particles are along the x-axis. Even the same formula can be applied if the two particles are along the y-axis there. If the two particles are along y-axis, also we will use the same formulas if they are the two system of particles. Okay, now we will see there the system of multiple particles of the body. So multiple particles of the body, collection of the masses of the particle, how the center of mass, how the position of the center of mass can be find. So that will be see there. Before going to that, so general formula, suppose here we have seen there two particles, two system of particles, only two particles are there. Suppose like that n number of particles are placed along the x direction or along the y direction, then what is the general formula for the center of mass? That we will be see. Okay, position of center of mass of system of n number of particles. N number of particles. N number of particles. So how to find out the center of mass if n number of particles are placed along x-axis or along y-axis there. Suppose if n number of particles are placed along the x-axis, so like this n number of particles are placed along the x-axis. Let us consider here it is a y-axis and this will be along the x-axis, you consider there. So there are n number of particles are placed, n number of particles here, mass particle 1, particle 2, particle 3, particle 4, so on up to n particles, if n particles are placed. So let us consider this is at origin and from the origin it is at a distance m1, at a distance let us consider it is a distance x1, and this m2 particle has a distance x2 from the origin, and m3 particle has a distance x3, and m4 particle has the distance x4 like that, n number of particles. So here xn distance, the mass of the nth particle has the distance xn. Then so this particle mn particle there. Okay. So how to find out the center of mass? So we can find out. So from the principle of momentum, we know that the mass of the system, mass of the n number of particle of the system can be represented as, here we can write there capital M. So that is equals to m1 plus m2 plus m3, so on up to mn, So now from the principle of moment of masses, we can write here. So let us consider somewhere here the center of mass will be present. So somewhere here the center of mass may be there, that the distance of the center of mass from the origin, let us consider that is xcm. So let us consider here it is there. Okay. So now from the principle of momentum we can write here. So principle of moment of mass, so mass of the center of mass and the distance is xcm, we can write here xcm, that is equals to, so m1 into distance of this particle from the origin, that is x1 plus m2 x2 plus m3 x3, so on up to plus mn xn. So therefore the center of mass can be written as xcm is equals to, so m1 x1 plus m2 x2 plus m3 x3 plus so on up to, we can write here mn xn divided by m. So here even we can write this m is nothing but m1 plus m2 plus m3 up to so on up to mn. This is the center of mass of the particle. If the particles are placed along the x-axis, n number of particles are placed along x-axis, then the position of the center of mass can be given by the general formula, that is m1 x1 plus m2 x2 plus m3 x3 so on up to mn xn divided by whole mass of the system of the particles, that is here capital M. Even we can write here m1 plus m2 plus m3 up to mn. Okay. So this is a today class, children. Understood now everybody? So tomorrow we are going to see the center of mass. If all the system of particles are along the y-axis, then what is the general formula? So now here we have seen that today the center of mass of the system of two particles, and what is the center of mass, and then system of particles of the n number of particles along the x-axis, that we have seen there. Then tomorrow we are going to see the center of mass, position of the center of mass along the y particle, along the y-axis. All the particles are spread over the y-axis. Then how to find out the center of mass? Okay, position of the center of mass, that will be see there tomorrow. Okay, so understood, children? So that's all for today class. So tomorrow we'll continue. So note it down this one.